Welcome back. If you're completely exhausted by trying to untangle those messy, disconnected webs of machine learning operations, well, you are in exactly the right place today. We are exploring the HumAIne AI Workflow Scheduler. Think of this thing as your ultimate MLOps master control center. It's an open-source, highly modular tool that basically takes all those repetitive, fragmented tasks and turns them into one smooth, organized, and totally reusable engine.
Here's our quick roadmap for this explainer. First up, we'll tackle the headache of fragmentation. Then, we're going to map out the core architecture and finally, wrap things up with automation and scheduling.
All right, part 1, the problem and market need and how we actually overcome this fragmentation. Okay, let's dive into this. Think about the limitations of traditional static pipelines. They're rigid, the tools are fragmented, and honestly, you just run into automation roadblocks at every turn. It's like hitting a brick wall. But contrast that with HumAIne's approach, pattern-based orchestration. By utilizing really intuitive drag-and-drop templates, it takes those scattered MLOps tools and literally snaps them together into a single, unified, interactive environment. It's absolutely crucial for bridging that gap for real-time integration. So who actually benefits from crushing this fragmentation? Honestly, pretty much everyone touching AI. We're talking academic researchers who are building out complex human-AI collaborative workflows, MLOps teams who are aggressively scaling up their deployments, and system integrators who are just trying to juggle a massive, messy mix of heterogeneous tools for their clients. And you know the absolute best part? Because HumAIne is entirely open source, the barrier to entry for all of these groups is practically zero. It's totally free to use and customize to your heart's content.
Moving right along to part 2, let's look at the core architecture, specifically building out a secure, layered orchestration.
Now, before any workflow actually runs, we have to make sure it's completely locked down. So the system is built right on top of multi-tenancy and robust security. Thanks to Kubernetes namespaces and role-based access control, or RBAC, it's essentially like giving every single project its own completely soundproof room. Multiple teams can easily work on the exact same infrastructure simultaneously, and they'll never step on each other's toes or, more importantly, compromise sensitive data.
So with the security totally locked in, how does the actual work get done? Well, the real secret weapon here is HumAIne's two-layered orchestration architecture. It solves that fragmentation problem we talked about by uniquely dividing the labor into two very distinct camps. You've got AI sequences on one side and event-driven integrations on the other.
Let's break down how these two layers create just this perfect partnership. Level 1 handles your AI sequences, and it does this using an Elira-based visual plugin. You can think of this layer as the heavy lifter. It's doing all your data fetching and model training straight from Jupyter Notebooks using a super simple drag-and-drop interface. Meanwhile, Level 2 handles your event-driven integration utilizing the Node-RED platform. So if Level 1 is the heavy lifter, Level 2 is essentially the nervous system. It's asynchronously coordinating live, real-time user feedback and all your external messaging mechanisms.
All right, on to part 3, automation and scheduling. Let's talk about how we actually deploy these powerful workflows. Let's move to and see how this builds out, because the deployment process is remarkably straightforward. Step 1, you just export your completed workflows as YAML files. These files conveniently pack all your container and dependency definitions right in there. Step 2, upload those YAML files straight into your user dashboard. And honestly, that's it. Your workflow is live and totally ready for execution. But, of course, once it's deployed, you aren't just crossing your fingers and leaving it to run blindly. By leveraging the Kubeflow Pipelines API, you get true, fully automated operations. You can programmatically trigger runs, comprehensively monitor their progress, or instantly halt executions if you need to. It literally gives you total command over the entire machine learning lifecycle.
Now, for true, hands-off automation, we're relying on time-based scheduling. The absolute magic for this happens back in that Level 2 Node-RED environment we just talked about, and it uses two highly specialized workflow nodes, the recurring pipeline schedule node and the event listener node.
First up is the recurring pipeline schedule node. Think of this one as your highly precise MLOps alarm clock. You just feed it your start times, your end times, and your exact intervals, and it takes over completely. It dynamically or statically drives your ML pipeline runs right on schedule. No manual intervention needed.
Working perfectly in tandem with that alarm clock is the event listener node. This one acts like a continuous radar. The exact millisecond your scheduled execution begins, this node detects it and outputs specific run identifiers. This is absolutely crucial because it ensures your dashboards and any external messaging systems are instantly notified and kept perfectly in sync with your AI tasks.
And that brings us to the ultimate value of the HumAIne workflow scheduler. It replaces those static, frustrating bottlenecks with an open, layered architecture, bringing both your ML sequencing and your event-driven automation under one highly secure roof. So I'll leave you with this to think about. If you could stop wasting hours fighting with fragmented tools and finally let a unified real-time orchestration framework do the heavy lifting, what massive AI problems could your team actually solve? It might just be time to find out. Thanks so much for joining me on this explainer, and keep learning.